continuing here in section 12.1, talking about congruency among triangles. And so we have some congruence conditions that if they happen, they guarantee us that the triangle must be congruent. So the first one is what we call side-side-side congruence. And we notate that with SSS, okay, for side-side-side. And what it means is that if all three sides of our triangle are congruent, well, the only way that fits together and makes a triangle is if all the angles are also congruent. And so what this says is that if three sides of a triangle are congruent to three sides of a second triangle, then the triangles have to be congruent. So think about this. I don't know if you have ever thought about this before, but when people are building buildings, if you go into like the Davis Event Center on campus, or you were to go into, let's say, the Bancorp South Center, or some really large building, if you look up at the roof line, a lot of times you will see the rafters that kind of go like this, where you have two metal bars or metal beams, and they're kind of made like this. And you have triangles that are formed. And the reason for that is because a triangle is a very rigid figure. Triangles, if you are building something, so I'm not very good at building things, but occasionally I will build a shelf, or I'll build something of that sort. And I have a shelf that I built just kind of with some leftover lumber, and I put the two sides and I put some shelving across it, but when I got it done, it wobbled a lot. And it would almost fall over, wobbling right to left. And so what I did was I took a piece of wood from the top corner and extended it down to the bottom opposite corner so that it was a diagonal across the back of that shelf. And when I put that in, it made it very rigid. It won't wobble now. And the reason is because a triangle is a very rigid structure. So if you take three side lengths of a triangle, let's say you take a side that is 2 inches, 3 inches, and 4 inches. Well, if you put those three sides together, it is going to form the same triangle every single time. So one of the activities that I used to do when I taught this in high school is I would give students some straws, and I would ask them to cut it into different size pieces. And so what you would have is if they all cut the same size, so I may say cut one's 2 inches, one 3 inches, one 4 inches, and then I would give them some string, and they would put their string through it, and they would connect it, and they would tie it off tight, and every single time they had the same triangle. Every single time. There was no way to not have the same triangle, because this side-side-side congruence guarantees that if all the side lengths are the same, then your triangles have to be congruent. Okay? And so we're not necessarily going to try to prove that, but that is something that we will use a good bit to show that triangles are congruent. Okay, so side is one way that we can show triangles are congruent. So let's take each of these triangles and let's show that they are congruent. And explain why they're congruent based off this side theorem. So these two triangles, we'll start here at the top. These two triangles are congruent because side BC, so that segment, is congruent to side DF. Now notice that it has to be DF, okay? Because if you look at angle B, the two sides of that angle are this length of 2 and 3. Well, the same angle in this other triangle has to be angle D. And so because of that, angle B and angle D have to correspond. And so we're going to say that side length DF is congruent to segment BC. And then we could also say that segment AC is congruent to segment FE or EF. Again, which one? Well, angle A corresponds to angle E, because again, if you look at what are the side lengths of that angle, well, you have the 3 and the 4. Well, the 3 and the 4 here means that angle E and angle A have to correspond. So we're going to call this side, if we said AC, we've got to say EF. Okay, so those two sides are congruent, which means that the other set of sides is also congruent. So I'm going to call it AB. And again, we see it has a length of 3. And again, angle A and angle E are congruent. And so we're going to have to call this length of 3 ED. So now when you look at that congruency statement, you should see that angle B and angle D correspond. And you can see that. And then angle C and angle F correspond. And then you can see that going across, angle A and angle E also correspond. And so you could take this one that's on the right, and if you could think about flipping it over to the left and then rotating it, then you could make it fit on top of that same triangle ABC. And so because of that, based off our side congruency statement, those two triangles must be congruent. So you can see how we would write that. We would say that, again, just like we did, each of those sides are congruent. So triangle ABC is congruent to triangle EDF. Again, notice that the order of the letters is important. Okay, make sure the corresponding angle measurements all line up together. If you have any questions about that, again, let me know. Be glad to answer any questions. And then if you look at the next one, this one maybe is a little more difficult to show, but if you were to take the right side of this triangle, or the triangle on the right, and flip it over that dotted line, you would see that it lines up on top of the other. And so as we're trying to prove that these two triangles are congruent, again, using our side, well, we could start by saying, well, side BC is congruent to side BC. Right? They're actually the same side in this case. We still call them congruent, but they are the same side. So, if that's the case, then side BA in the triangle on the left has to be congruent to side BD, the one on the right. And then also AC, that segment, has to be congruent to DC. And so again, because of that, because we can show that all three sides are congruent, then we know these two triangles have to also be congruent. And so again, that's what it says here. Each of those being congruent, and so therefore the triangles are congruent. That's a very simple version of the way a proof is going to work. As we talk about proofs here in a little while, we're going to say, okay, we know this, and we know this, and we know this, and based off of maybe a theorem or some other definition or whatever, we know this thing, and so that leads us to our conclusion. And so as we begin kind of talking about what is a proof going to look like, that's it. We're going to say, okay, we know this, this, and this, and because of that, we have something that is congruent. So side is not the only way that we can show triangles are congruent. So we'll talk about another way in just a minute. But before we do, let me make sure you understand this. When we talk about triangles, there's a rule that we have to have that says that the sum of the measures of any two sides must be greater than the third side. So think about that. If I were to tell you, just give you a little sketch here, that you have a side length of 2 inches and a side length of 3 inches and then a side length of 4 inches, and we can connect those or not for this illustration, it should make sense, hopefully, that in order for this side length of 2 and this side length of 3 to be able to form a triangle with this other side length, that other side length could not be 5 or more, right? It would have to be less than 5, because if you had, let's say, a side length of 2 and a side length of 3 and then a side length of 6, well, there's not going to be a way to make those form a triangle, because if you take this one and stick it there and this one and put it there, well, we don't have a triangle, right? Because that length of 6 is too long. It's not going to be able to actually form a triangle where you have some space in here like we do in that first example. And so, again, I think I could prove this to you. If you were to take that straw activity that I talked about earlier and you were to cut out pieces of straw and run a string through them, you would notice that no matter what sizes you choose, every time two sides have to be greater than the other side. Every single time. And so typically we say, well, the two smallest have to add to be more than the longest. And that is true. And so as we talk about triangles and congruency and some of those things, it is important to understand that you cannot have a triangle where one side is longer than the other two combined. Okay? So, there will be some common triangles that we'll talk about. For example, a 3, 4, 5 triangle is a right triangle, and we'll reference that a little bit. This 2, 3, 4 is even a common one as far as thinking about side lengths and how long they can be. But I hope that makes some sense to you, that the third side cannot be longer than the other two combined. Okay? All right, so our next congruency statement is what we call side angle side congruence. And so what it says is that if two sides and the included angle, so side angle side has to be in this order. You have one side, you have an angle, and then you have the adjacent side. So it has to be in that order. For example, if we're talking about this triangle, for this to fit side angle side, it would have to be this side, this angle, and this side. Okay, that's going to be your side, angle, side. We do not reorder those letters, because if you were to reorder them, then you're not talking about the same thing. So when we talk about these, if we're talking about angle measurements, there will be one later that's angle, angle, side. Well, that's going to be an angle, another angle, and then a side, like that. And so the order of these letters does matter. In side angle side, this angle has to be between the two sides. Okay? And so what it says is that if these two side lengths are congruent and their included angle is congruent, then we have to have a congruent triangle. And that, if you again think about this a little bit from an outside the box standpoint, that should make some sense, because if this side length is known and this side length is known and this angle is known, well, if you extend those out and make a triangle that goes from this point to this point, there's only one option for this other side length. It has to be the same all the time if we have those two sides and their included angle. And so that's, again, not something we're going to try to prove, but that is something that we will use in some proofs, is that, well, if we know the side angle and the other side, that included angle between the two sides, then it has to be congruent. So let's look at a very basic one here. So with this one, we want to use side angle side to show that the given pair of triangles are congruent. So again, we want to show a side, we want to show the included angle, we want to show the next side. And so in this case, we're going to start out by showing that side AB is congruent to side ED. So again, the order that has to matter. So there's one side. We also want to show that angle B is congruent to angle D. And then we want to show the other side, the next side is congruent. So in this case, BC, that segment, is going to be congruent to DF. Again, the order does matter here. And so because of that, we've shown that a side, its included angle, and the next side are congruent. So therefore, the triangle ABC must be congruent to the triangle. Make sure we have all the letters in the right order here.